we have a wooden block of mass 1 kilogram that is released from rest on a rough plane, which is quite important, on an incline of 20 degrees above the horizontal. The coefficient of friction, so there is a coefficient of friction, which we already knew from the rough plane, between the block is 0.2. So the coefficient of friction has a symbol called mu, that's equal to 0.2. Find the acceleration of the block. Okay, before anything, let's draw the system. So we're going to have our flat surface. That's going to be inclined by 20 degrees to the horizontal. We have our block on this inclined plane. That has a mass of 1 kilogram, but remember we're considering the weight component, so that's going to be 1g. Let's also consider the other forces that we have. We have the normal reaction force. That's not straight. Let's draw that straight. We have our normal reaction force acting perpendicular to the block. We also have the component of the weight parallel to the slope, which is 1g sine theta. And also the component of the weight perpendicular to the block, which is 1g cosine theta. Now we also need to consider our frictional force. Now our frictional force is going to be opposing the direction of motion. So if we assume that the block is accelerating down the slope, then we're going to say that the friction is going to oppose the direction of motion, and it's going to be in this direction. Now what equation is going to govern this friction? Well, that's actually going to be Fr, our frictional force, is equal to mu n, where n represents our normal reaction force, which we have here. So that's going to be mu n. So now that we've labeled all of our forces, we can actually go on to solve the question. So what are we trying to find? We're trying to find the acceleration of the block. Well, in order to find the acceleration of the block, the first thing we need to do is find that normal reaction force, right? Because we cannot solve parallel to the slope if we don't know what the normal reaction force is. That's going to be quite simple. So if we apply F is equal to ma, and we apply that perpendicular to the slope, taking up as being the positive direction, that's going to be n minus g cos theta is equal to ma, but acceleration is 0 in that direction, so it's going to be equal to 0. So the normal reaction forces are going to be equal to g cos 20, because theta is 20. So now that we know what the normal reaction force is, we can actually solve parallel to the slope. So again, F is equal to ma. Let's assume that the block rather is accelerating down the slope. So let's take down the slope as being the positive direction. It's a bit wonky there, but it doesn't necessarily matter. So that's going to be g sine theta, or sine 20, because theta is 20, minus mu n is equal to ma, but m is equal to 1, because the mass of the block is 1 kilogram, so it's just going to be a. We know what mu is, and we know what n is from before, so we can just substitute our values in. So it's going to be g sine 20 minus mu is 0.2, n is g cos 20, and that's equal to a. So if I get my calculator and I put in 9.8 sine 20 minus 0.2 times by 9.8 times by cos 20, that is going to give me an acceleration of 1.51 meters per second squared. So a is then equal to 1.51 meters per second squared, and that's given to 3 significant figures. So I hope that was useful. If you have any additional questions or any further questions, please leave some comments below, and I'll see you in the next video.